everybody, this is Mrs. Hopley. Today, we're starting our new unit. So our objective for today is we can write a fraction with a denominator of 10 as an equivalent fraction with a denominator of 100. So we're going to be figuring out 7/10 equals some hundredths. All right, let's get started. So this is your independent work for today. We're going to be filling in this table. The first one is done for us. So we'll be looking at a model. In this case, we have both models. We're going to label the fraction or fractions, in this case, that are represented, coming up with equations, and then finally listing the equivalent fractions. So first things first, we need to figure out what fractions are shown here in these first two models. So before I even try to label these models, I notice that they are equivalent. How can I notice without doing any math? I'm just looking at the shaded part. So if I look at this first part, I can see that there are 1, 2, 3, 4, 5, 6, 7 columns shaded. So that's going to be my numerator out of 8, 9, 10 columns total. And so that just leaves this, last part here unshaded. That same exact portion is left unshaded in this model here. So this is showing me 7/10. Let's think for a second. Would it be reasonable for me to count up all these itsy bitsy little squares? I hope you're at home saying no, that's not reasonable. Instead, we can think of this as an array. We can figure out how many rows are there and how many columns. So I'm going to count. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So 10 by 10 means there's 100 total parts. Okay, so each column then is how many units? This column has how many units? 10, good. This column is also going to have 10. So let's skip count by 10 and see how many units are shaded in all. This is 10, 20, 30, 40, 50, 60, 70 units are shaded in all. All right, so this model is 7/10. This model is 70/100. I can see in the middle they have an equal sign, so I'm going to write that here. 7/10 equals 70/100. Okay, there's a few different ways we can think about this and prove that those fractions are equal. And we just did the first way. We looked at a model and noticed that the same portion is shaded, even though this is showing us much smaller pieces here. The second way we can do that is with math. So the equation is already written for you, or actually typed into this box, but I'm going to write it out so it's a little bit more clear. So I know if I take a fraction and I multiply by a fraction that's equal to 1 whole, I can get an equivalent fraction. So the skill, I'm going to take my little sticky back, is figuring out equivalent fractions with denominators of 10 and 100. So I want to figure out 7/10 is equal to how many hundredths. So to figure out which fraction goes here, I need to think, 10 times what will give me 100? All right, so that's a fact I think most of us know, 10 times 10. And if I want to multiply by a fraction equal to 1 whole, I know the numerator needs to be the same as the denominator. So I need to multiply by 10/10. So when you multiply by a fraction equal to 1 whole, you get an equivalent fraction. We don't want a bigger fraction than 7/10. We want an equivalent fraction that just has more smaller pieces. And that's exactly what we're going to get. So 10 times 10 gave me 100. 7 times 10 gives me 70. And what do you know? We got the same answer. 7/10 equals 70/100. 70/100 equals 7/10. And that's what we have here as our answer. All right, we will do one more together and then you guys are on your own. Let's look at number 2. Okay, first things first, let's take a peek at that model. How many total parts are